Hi, this is Park Chang. In this lecture, we'll talk about the cosmology theory. Okay. The reason why we study cosmology is because we want to find theory which works on every universe. And the theory has two theory. One theory is quantum mechanical theory, and one theory is general relativity theory. And when scientists unify this theory, we call it as SUSY theory, which is supersymmetry theory. We call it as grand unified theory. But within 50 years research, we should know that this theory doesn't work universally. You can find counterexample. If you hold a pencil, whole gravity from universe works on this pencil. And if grand unified theory works, then within this gravity information, we should know the quantum mechanical information. The gravity has infinite range and quantum mechanics has finite range, very short range. And this is why grand unified theory doesn't work. See like this. If whole gravity on this pencil can be converted to quantum mechanical information, then whole universe, the whole information from universe should be gathered into this pencil. But before that situation, the pencil should turn into black hole. But pencil is not black hole, and the size of the black hole should be very big, and pencil is very small. So this is the counter example why grand unified theory doesn't work. And as you see, the reason why grand unified theory doesn't work is because gravity has infinite range and quantum mechanical effect has very short range. So the communication between infinite and short is impossible, and this is why grand unified theory doesn't work in this situation. But this is very beautiful theory. So there must be a space where this works well. It is called as black hole. In black hole, there is a two situation. There is a two property. One, every information, including gravity, is much faster than light. It goes faster than light. And this is the reason why general relativity and quantum mechanics can communicate with. And next, entanglement entropy of black hole is maximum, which means the quantum mechanics and general relativity has entanglement between them, and the entanglement itself is very big, so we can know quantum mechanical information from gravity and gravitational information from quantum mechanics. So this is the two property why grand unified theory works on black hole. And as you see, the process is seen like this. When a particle gets inside the black hole, which has sphere shape, particle should entangle with the surface of black hole first, So there should be an entanglement between particle and black hole. And this quantum mechanical effect can be analyzed by CFT theory, which is Conformal Theory. And this is also called as N equals 4 Super-Yang-Mills theory. So, and after it gets through this surface of black hole, which is event horizon, you can the particle get inside the black hole. Get inside the black hole within gravity. So, in this space, there's only a gravitational effect, which can be analyzed within AGS 5, which is untitled space, and this is just normal gravitational space. And this phenomenon is called as ADS CFT correspondence theory, because we can know gravitational information from quantum mechanical effect, and we can know quantum mechanical effect from gravitational effect. This is exactly what you want to know. And this is the one-way truth that grand unified theory works in black hole. And as you see, inside the black hole is 5-dimensional, and the surface of black hole is 4-dimensional. And the reason why this happened is because inside black hole the gravity is much faster than light, and the entanglement is maximum. Yes, you might know what you have to know. Okay, then next we will learn more about the geometry of black hole. Geometry of black hole. To learn about the geometry of black hole, we should observe that from outside the black hole. So this is the maximum black hole in the universe. When you shoot a light, it is 1 light year. This means when somebody shoots a laser from one point, it took 1 year to get to the other side of the point. This is the definition of 1 light year. And the maximum black hole has 1 light year radius. And this is the observation from outside the black hole. But when we observe this in the inside the black hole, we call it we can observe quite strange effect, because the light should because you can think like this. This is the inside the black hole. In the inside the black hole, you get sucked into this singular point, and this is the event horizon, which you pass through just before. And you shoot a light to the event horizon, but this is impossible, because the gravity, the curvature of black hole is infinity. So light cannot escape even 1 centimeter or 1 millimeter or 1 mile. So you should get sucked into this way, and it will never reach the event horizon. So this is why the radius, which observed from inside the black hole, is infinite, which is not finite value. 1 light year finite value, but infinite is not finite. So you can think this is quite strange, but if you observe the if you observe the sphere, if you observe sphere with infinite radius, you can know the dimension of surface is 4-dimensional and dimension of bulk is 5-dimensional, which is exactly same with this situation. The surface of black hole was CFT, which is 4-dimensional, and the bulk of black hole was 5-dimensional, which is 85. So the region ADCFT correspondence theory, which is the grand unified theory in the black hole, works in this black hole is because black hole has the geometry of infinite. This is why black hole has infinite geometry, and grand unified theory works in that place. Thank you. This was Park. Okay. Thank you, my friend. And the meaning of this lecture is using this geometry, you can prove Riemann hypothesis. Riemann hypothesis include infinite value, and if you observe the prime number of on this surface, you can easily find that the condensity of this prime number, which is infinite, but you can easily prove with the experimental effect of black hole. So you can prove Riemann hypothesis within this black hole effect, black hole geometry. So thank you, my friend.